The best way to start by doing the simplest thing that could possibly work is to do what I call incremental thinking, which is an engineering discipline. In particular, what it means is splitting a problem into smaller problem and then solving each problem separately, sometimes by doing prototypes, sometimes by actually implementing it, sometimes by figuring out the solutions that will not work for that particular problem. And this is what I'm gonna touch more on today with a few examples. So not in a lot of depth, but with a few examples. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today I want to talk about incremental thinking. And the reason I'm talking about this is because our previous video on doing the simplest thing that could possibly work has caught a lot of attention, but we didn't get a lot of comments. So based on that, I figured probably this is what people would like to learn more about, doing the simplest thing that could possibly work. And there are some ways of dealing with that. Now, if you thought that that video is about something else, or if you found it interesting for other goals, then please add some comments, because that's how we'll know what to talk about in the future. But until then, let's go back to our topic. So we will be talking about a few examples of incremental thinking. Let me first state that incremental thinking is an old engineering practice. Incremental thinking is how bridges were built, right? How do you build a bridge when you don't know the physics of the bridge? Well, there are a few ways of doing that. You could perhaps do a small scale prototype and try to figure out the forces. You could think about the simplest bridge that could possibly work, and people have done this for years. What is that? Well, maybe you just put a log over a river and pass over it. And then you realize that maybe the log will roll out with you, and so maybe you need to fix it somehow. And then you realize that maybe the water will come over the log, and then you need to raise it a little bit. And then you realize that maybe the log is not the best thing to pass over, so then you need to cut it and make it a little smoother, if not perfectly smooth, so that you can actually walk on it. And then you realize that since you have planks, maybe you can put planks one after another and link them together with rope, and you get a rope bridge, and so on, until you get modern bridges that use very complex designs compared to these ones. But what's really at stake here is you start from a problem. The problem is, I want to pass over a body of water, and then you figure out what's the smallest thing you could do to make that happen, or you split the problem into multiple smaller problems. Like maybe you realize that you need something to pass over, you need something to hold the bridge in place, and then you start working on each of those separately. This is very similar with what we as software engineers are supposed to be doing with software development, with one big difference. And the difference is we can prototype much faster, because this is software, and software is soft, which means that you can change it. Okay, but the thing is exactly the same idea. Now let me paraphrase this a bit by saying that incremental thinking is useful at every single step in software development. It's useful in analysis, it's useful in software architecture, is useful for defining a product. What is MVPs? What are MVPs? Most, if not the smallest increment, splitting a problem into smaller problem, figuring out what audiences might like that problem until you reach product market fit. So you have this at product design, you have incremental thinking at business analysis, you have incremental thinking at software architecture level, and then at implementation, and then at testing, and at infrastructure, and in the tooling of your CI and CD pipeline, everywhere. So if there's one skill that you should learn, and that will apply everywhere in your activity as a software engineer, that is incremental thinking. But incremental thinking has its challenges. This is why I'd like to give you some examples. And I'm going to give you an example from when I was doing a kata. I started writing a book on test-driven development, which I haven't finished, but maybe I'll finish at some point, because I actually like, and I haven't seen this approach in other books of test-driven development. It's a, let's say, more structured approach focused on learning the technique. But I never finished it, and maybe I will at some point, but that's not currently in the works. And for that book, I started thinking, okay, what kind of problem could I try? And back then I was focused a lot on games, because I like games for katas, for software development problems, particularly for training these types of techniques like refactoring, test-driven development, clean code, etc. And the problem I decided to try was Tetris. Now, of course, I would never dream of implementing Tetris, because that is, some companies have rights on the name, and so it's a blocks game. Okay, let's say it's a blocks game. Blocks are falling, and you can move them and put them in place, and you get lines, and you remove those lines when you fill the lines, and you get a score somehow based on all that. Now, the way you would start to implement this, there are different ways, right? Now, knowing about game engines, if I were to start with a game engine like Godot, then I would start completely differently. Although, if I think about it, maybe not. Because you have the notion of scenes in Godot, you have the notion of objects, and those objects kind of update based on a tick. And you have some things that are built in, and that makes your design easier, let's say, and your prototyping. But let's assume we are starting from scratch. We have nothing, no game engine, no graphics engine. And the problem is, what I wanted to do is to start from purely abstract implementation, just, let's say, the algorithm, and then plug the graphics on top of it. And you know what? It actually worked. But the story is how I got there. And I'm going to give you first the heuristic. And the heuristic was pick the smallest or the simplest game similar to this blocks game that would make sense. Okay? So what would that be? And I'm pausing on purpose because I'd like you to think a little bit about that. All right, here's what I did. I said, okay, so we have blocks that are made of 4 dots in different combinations, technically called tetraminos. And they are falling down in something called the well. The well, if I remember correctly, it has 20 depth or something like that. So you have 20 steps down. Okay, so what would be the simplest game that is similar to this, even though it might be very silly? Well, how about a single block, 1 by 1, that falls in a well that is only 1 width, and that falls down, let's say, 2, maybe 3 spots. So the height is very small. I think initially I actually did it with 10 or 20, so with the correct height, but you can actually simplify it and say, let's just make it 2. You could make it 1, but then it's just silly. So let's just make it 2 or 3 so that it falls once, twice, and then it fills the line, so it needs to disappear. Okay. Now, is this an increment that you could show to your product owner and they would say, yeah, this is what we are looking for? Probably not. And that's one of the challenges with incremental thinking, but we'll get back to that. But it does show the important parts of the game, which is you have blocks are falling, they stop at the bottom, they can stack over one another. That's another thing, because the next test is, so 1 block falls down, the next test can be 2 blocks fall down on top of the other, in which case you don't remove the lines, because you just want to implement the part where they stack on top of the other. And then you can go even further and say they stack all the way up, you don't remove the lines, and until the game ends, because it's game over when you go to the top of the well. Right. So with this implementation, you touch on the most important parts of your problem, but without introducing unnecessary complexity, which will be eventually needed, of course. And let's say you have the 1 by 1, you have the, 1 width well, and let's say it's 20 height, so it's 20 by 1. The next step would be to expand it to allow for lateral movement, but you are still moving a single 1 by 1 block. You are moving it left, right, and you process that while it's falling. And then if you expand this, you can also implement line removal. And then if you are doing that and everything works with a 1 by 1 block, you can then introduce the different pieces and the rotation. First, the rotation, you can rotate the piece. And then when it falls down, you need to update the way you compute that the lines are filled. Or maybe you don't if you wrote it from the very beginning by separating the piece from the line, which is, maybe a good idea. So you see how you take a problem and you imagine how it will grow in time. And this is what I call incremental thinking. Another way of thinking about this is that you split a larger problem into smaller problems. So how would you do that? Well, the way I got to this simple problem initially was not through the shortcut, was not through the heuristic. Instead, what I did was what we at Mozaic Works call behavior slicing analysis. Basically, I wrote a bunch of test descriptions in the form: for this input with this behavior, you get this output. And what you have is a piece falls down, stops at the bottom. Or a piece falls down one level after one tick. A piece falls down two levels after two ticks, and so on. When the piece ends on the bottom, then the piece stops, and so on. And then you go to, that's, the actual description of the game, but then you need to go into implementation. And you think, okay, so what's the smallest, the simplest piece, and what's the simplest well that I could use? Just break the rules a little bit, simplify everything for the goals of my tests. Because I know I will eventually increase it, but it doesn't really matter. I can ignore everything else. I'm just focusing on one behavior, which is the piece falling down. So in that situation, the only thing I need is a one with well. So that's another way of getting at it, which is you do this behavior slicing analysis, which starts by stating the cases, and then you do equivalence partitioning. So you figure out what are the inputs, what are the outputs, and how many different inputs would match outputs in the equivalence classes. And then you realize what is the simplest thing that you could start implementing. Another factor here is how easy it is to implement the tests, because this tells you a lot. If it takes you a long time to write the first test when you're doing test-driven development, then something is wrong. And by the way, when you do test-driven development, that's very different from writing tests on existing code that doesn't have tests. That's a different problem. It's called the legacy code techniques. And many people confuse these two. But test-driven development is about solving a new problem, sometimes within an existing system, but usually writing the first test should be very, very simple, because you start from the simplest problem that you can imagine. So these are two approaches to the same problem for software development. Now, these relate a little bit with the slicing patterns for user stories. And let me give you again an example. Let's say you have a screen that's a form where you need to enter 20 different inputs, and you need some kind of complex validation, and you need to process those, compute something, save in the database, call 10 different microservices, and wait for the answer. All right? How do you deal with that? And how do you make the simplest problem, the simplest thing that could possibly work in this context? Well, there are a few pieces or a few areas where you can simplify. First, the form. You have 20 data items in the form, but what if you only work first with the mandatory ones? Maybe those are 2 or 3. What if you don't validate those at all? And you just make them work without validation? What if you hard code some of the values? If you absolutely need them, maybe you hard code them in the backend and you make sure that things work. What if you don't call the microservices, but instead call a stub? And I mean, or a mock object. And of course, this can bite you later, so be careful how you are calling it. Be careful that the integration works. Another way of thinking about this is, what is the riskiest part of this whole thing? Is it the call to microservices? Then we can start by implementing that call with hard-coded values and see that it works. And once that is done, then you can move to the next things. Or maybe instead of doing the whole UI, which needs to look nice, and maybe you need some animations and some validation and so on, maybe you do a command line interface and you call it through curl, for example, and you do curl this API with these values, and you verify that it works. So these are a few examples of how to simplify things. And now I know people will start saying, but look, my product owner only says that it's finished when everything is in place and so on. That may be true. And this is one of the challenges of incremental thinking. So there is a tension between doing the simplest thing that could possibly work and doing the thing that pleases our product business people. Which raises an interesting point, which is you need to be smart about it. Figure out what it is that the product owner is really needing. So when you look at that feature, what is the smallest thing from that feature that is actually relevant to the whole thing? Is validation the most important thing? Is saving? Is the report that is resulting from that? What is the most important thing that they are looking at? And once you understand what is the most important thing, that's the one you should do first. Now, sometimes this doesn't work because you have some technical risks involved, and that's when you need to explain, well, so this is what we would do normally, but we have this technical risk involved. For example, we have a new technology, we don't know how to use it. We need to figure that out. And so our first increment will be smaller than that, just to prove that the technology works. And then we'll move into what is really interesting for you. And this is a good dialogue to have. So these are a few examples of doing incremental thinking, but we can go even further. So let's say I want to talk about another pattern, which is called 0, 1, 2 more. This is a very useful pattern. So let's say you have a list of items that you need to show. Or maybe in your form you also have a list and people can introduce items in the list. Let's first remove the list completely and we have 0 items there. And maybe hard code if we need an empty list. Or if it shouldn't work with an empty list, then a hard coded list with 1 item. Then we allow the users to select one item. Then we allow them to select multiple items. This works great for a lot of situations. This works great also when you are implementing the code. So if you're doing test-driven development and you use lists, you might start by calling the function that you're testing with an empty list and check that everything is going correctly when it receives an empty list. And then a list with one item, and then a list with two items, and then a list with more items. And maybe there's not a big difference between 1 and 2, and you can just skip to more. Sometimes there is, so you need to pay attention to that. So do the simplest thing that could possibly works. It is very connected to incremental thinking. Incremental thinking applies at every stage in software development. You can define products using incremental thinking. You can define your features using incremental thinking. You can even define your architecture and your pipelines using incremental thinking. But then there's a whole cycle of always trying to simplify, which is where the questions that I talked about in our past video are really useful. And if you haven't seen that video, I invite you to watch it now because it's been quite successful for our channel. So what do you think about all this? Let me know in the comments. Would you like to see some more practical approaches to this? Maybe you would like to see some performed architectural katas where I use these principles. Yes, we have those. Some of them are recorded. We are planning more of them this autumn, and you can join us to see how you can solve even complex architectural problems through simplification and risk management. But look at all the aspects of software architecture. But whatever you want to see, let us know in the comments. It helps us a lot to know, and we want to do what's most interesting for you. Or if you have questions, comments, ideas, and if you like this, leave us a like, subscribe to the channel. We have videos coming every Saturday. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.